Namaste everyone, welcome to CET NEET classes. We are in ray optics now. We have finished 10 questions and this is the 11th question. So the question moves like this. It will be a convex mirror gives the image of an object 30 centimeter from it at the same point as a plane mirror at a distance of 5 centimeter from the convex mirror and 25 centimeter from the object. Find the radius of curvature of the convex mirror. Namaste. Did you understand anything from the sentences? It's totally confusing sentences. You should be very cool and you should be very calm and reading the problem while reading the problem. A convex mirror gives the image, right? A convex mirror first gives the image of an object. Where is the object? 30 centimeter from it. From it means from convex mirror. At the same point, so convex mirror gives the image of an object 30 centimeter from it, right? You have to read it like that. A convex mirror gives the image of an object 30 centimeter from it. It means it is not the image is 30 centimeter from it. You will come to know after completing the problem or completely reading the problem, analyzing it, you will come to know that this is not image distance, it is object distance. Convex mirror gives the image of an object 30 centimeter from it, where at the same point as a plane mirror at a distance of 5 centimeter from the convex mirror. It gives the image at a distance of of an object 30 centimeter from it. So convex mirror has an object 30 centimeter from it. It gives the image at the same point as a plane mirror forms the image. It gives the image at the same point as a plane mirror which is at a distance of 5 centimeter from the convex mirror and 25 centimeter from the object. Find the radius of curvature of the convex mirror. So in optics, what is the problem is you must draw a ray diagram. Most of the problems require a ray diagram if you are dealing with the lenses and mirrors. So that is needed because otherwise we can't analyze it. How is the situation and how the rays are moving, and choose the mirrors and lenses in such a way that rays of light are always moving in the plus x axis, otherwise we will be in trouble to apply sign conventions. Okay, now you have to place a convex mirror. Let the rays of light from the object move in plus x axis. Then how do you place the convex mirror? Convex mirror must be placed like this. It should be placed like this, no other way, because an object must be placed like this. And you know that in a convex mirror, I don't deal with whatever you get in the theory classes. A convex mirror always forms a virtual, erect and diminished image, right? Rear view mirror in vehicles, you know this. It always forms diminished image, wherever be the object, whatever be the distance of the object from the mirror, it forms always a diminished image. So the image of this object be somewhere here. It is always diminished, erect and virtual. That is why it is used as rear view mirror, because when you move in a vehicle, you may not be knowing it. There may be chances of vehicles coming from your backside at any distance. So it shows the image for all the objects. It covers all the world behind it, and its field of view is more. It covers everything. Okay. This is given. Now distances are given. A convex mirror gives the image of an object 30 centimeter from it. Okay. At the same point as a plane mirror at a distance of 5 centimeter from the convex mirror. There is a plane mirror at a distance of 5 centimeter from the convex mirror, and if plane mirror has to be placed, where you will place the reflecting side and silvered side? You see, from the convex mirror, and 5 centimeter from the convex mirror. Okay, this is 5 centimeter from the convex mirror and 25 centimeter from the object. That is obvious because total it should be 30. That you know. So an object has to be placed, a mirror has to be placed, and now their argument is the convex mirror forms the image at the same distance as at the same point as a plane mirror forms. If the plane mirror, for the plane mirror also this is the image, this should be the silvered side and this should be the object side, reflecting side. Now if both are forming the image at the same point, that object should be visible for both the mirrors, right? So I will extend the object like this. Hope you are following this. I will extend the object. Then the image is extended. Say this part of the object is seen by the plane mirror, so it forms the image here. And suppose this is to identify it like this, right? And this part of the object is seen by the convex mirror and it forms the image here. Now did you follow the sentence here? So understanding sentence is very important, but you need not worry, all the problems won't be like this with twisted sentences, so many grammatical the things inside it. It will not be active voice, passive voice and all those things, and it won't be so. But most of the problems will be easy. But this is the one where you will be trapped in understanding the problem. Once you were able to write the diagram, the problem is very easy. So a convex mirror forms the image of an object 30 centimeter from it at the point where the image is formed by the plane mirror, which is at a distance of 5 centimeter from the convex mirror. Now their question is, what is the radius of curvature of the convex mirror? If you want to know what is the radius of curvature of the convex mirror, you must find out focal length. Once you get the focal length, then you can do that. Now whenever a mixing of plane mirror is given, a plane mirror is kept in front of a convex lens, a plane mirror is kept in front of a concave mirror, all these things are given, plane mirror is given to give you a clue for you where is the image, or to find out some distances. Usually plane mirror is given, because in a plane mirror object distance is always equal to image distance. Now what is the object distance for the plane mirror? So now the things whatever I write is not given in the problem. Object distance is 25, shouldn't be image distance 25, it should be for a plane mirror. So to give that clue they are giving plane mirror, that's all. Now once the image distance is 25 for this, what is the image distance for the convex mirror? This is 25 and this is 5, 25 minus 5, that is equal to 20 centimeter, is it? So this 25 minus 5, this is the image distance for convex mirror. You got the convex mirror data, object distance, image distance. Why can't you find out the focal length and double it to find out the radius? And remember, for a convex mirror, radius should be positive, because if parallel rays are incident on a convex mirror which are moving in the positive x-axis, they diverge in such a way that they appear to come from a point here, focus. So the focal length is positive, right? Now it is your job, the mirror formula, 1 by f is equal to 1 by u plus 1 by v. No negative in the mirror formula, only in magnification negative. Whereas lens formula negative, 1 minus 1 by u. Whereas lens magnification, no negative. So 1 by f equal to 1 by u plus 1 by v, 1 by f is equal to 1 by u, object distance is in the left side, you divide this into coordinate system. When the ray is moving along the positive x-axis like this, all the things on the right hand side from the pole positive, left hand side from the pole negative, upwards positive, downwards negative. So minus 30 object distance plus image distance positive plus 20. You must get focal length positive. You will get this because this number is greater, this is smaller, negative smaller. So shall we solve it? Okay, answer is, hope you are listening, voice is clear. 1 by f is equal to, I will take 60 as common, minus 2 plus 3. 3 minus 2 is 1, 1 by 60. Focal length is 60 centimeters and radius is 120 centimeters. They are asking you radius. See whether you have answered their question or not. So after all, finally for completing this, if you tick 60, you are gone. It is as if you don't know the answer, isn't it? But you know how to do that, but you have not answered the question. That is very important. What they are asking you, sometimes in first year PU questions, a ball is dropped and what is its distance from the ground, they will ask. You will calculate the distance traveled, you will not calculate the distance from the ground, so you will be trapped. And that answer also will be one of the option, the distance traveled by the stone. What is its height from the ground, that is another option. So you will tick it, there is a chance. So see whether you have answered to the question or not. So it is 120 centimeter. Shall we move? Okay, sometimes we also commit the same problem, but in tension it happens so, but still you should be very cool. We shouldn't lose mark for the things what do we know. If you don't know and lose the mark, no problem. 12th one. A motor car is fitted with a convex driving mirror. You know, rear view mirror is convex mirror. A motor car is fixed with a convex driving mirror of focal length 20 centimeter. So shall I draw it so that I need not read the problem again and again. So there is a convex driving mirror and it is fitted with a lens of mirror of focal length plus 20. You know, just now we have seen focal length of a convex mirror is positive. A second motor car. So this is in a car, right? In that car you are sitting and you are looking into the mirror, and with respect to you the mirror is at rest because you are in the same car. Then there is another car coming from back. Now this is not up to the scale because this car is very small compared to the mirror of the first car itself, right? Then how larger may be this car? But simply just for our understanding we are drawing it. There is second car coming, car 2 meter broad. Of course finally you will find that that breadth of the car is not needed. 2 meter broad and 1.6 meter height is 6 meter away from the first car. Okay, if you want I'll write it. Breadth is 1.6 2 meter broad. Okay, height is 1.6 meter of this car, and it is 6 meters from the first car, away from the first car. Then the position of the second car as seen from the first car is, yes. It is a direct problem, isn't it? So I just see at a moment that there is this car at a 6 meter back. Where do you see the image of the car inside the mirror? Image distance, that's all. Image distance should be positive. You should get it as positive. Focal length positive, object distance negative. So you have to divide the coordinate system like this from the pole. Right, 1 by f is equal to 1 by u plus 1 by v. This is a very simple problem, but I want the next problem with this one. What is 1 by f equal to 1 by u plus 1 by v? 1 by f, where is 1 by f? Focal length. It is 20 centimeter. I will keep everything in centimeters. 1 by u, object distance 1 by minus 60 plus 1 by v, right. This is 1 by 20 plus 1 by 60 is equal to 1 by v. So that implies, I have a habit of writing every time 1 by v, right hand side or left hand side, because you will forget the left hand side. You will write only equal to. You will forget this one. Finally you will see that this itself is v, but it is not v, it is 1 by v. That is another dangerous part. Okay, what you will get now? 60 common, so I will write 1 by v. 60 common, 23 times plus 1. So what is 1 by v? 1 by v is equal to 4 by 60. That implies v is equal to 60 by 4, that is 15 centimeters. I think I have gone wrong because no answer. The position of the second car as seen from the first car. 1 by f is equal to 1 by minus u. Oh, it is from where did I get 60? It is 6 meters, that is 600 centimeters. Oh, that's where I have gone wrong. 600 centimeters, 600 common, then it is 30 times, right? This is 30 times, yeah, 1 by 600, that is 30 times, 30 times, and 600 one time, 31 by 600, this is 31 by 600, and 600 by 31, 30, almost 20 times, right? 30, 20 times, very close to 620 this one, but less than 20 centimeters, but less than 20 because this is 31, so this is the best answer. Just less than 20, that is the image distance. Now, my problem is not this one. This is an easy problem, direct problem. Next one. In the above question, if the second car is overtaking at a relative speed of 15 per second, so that car is, I feel that this car is moving at a 15 meter per second towards me. That is relative velocity, because I may be moving at say some 25 meter per second, and that car may be moving at say some 40 meters per second. So 25 meter per second, 40 meter per second. The backside car will be overtaking me with the 15 meter per second. So if the second car is overtaking at a relative speed of 15 meter per second, how fast will be the image moving? So as I see, the actual car is coming like this, image comes like this. At what speed the image is moving? When I find out the image distance or image velocity, we will use the formula. You know that the u is the object distance, it is not initial velocity and final velocity, object distance and image distance. If you want to find out the velocity of the image, in entrance examinations, best method is differentiation. See, you have 1 by f is equal to 1 by u plus 1 by v for the mirror, right? We got the image distance as 20 centimeter. Now, in a mirror, as the mirror is kept in the car, as you look into the object distance is a variable, image distance is variable, but focal length of the mirror is not variable. As the object moves and image moves, focal length is a constant. So differentiate this one. d by dt with respect to time, because with respect to time object distance and image distances are changing. So d by dt of 1 by f is equal to d by dt of 1 by u plus d by dt of 1 by v. So this is the way in which it goes. Now what is d by dt of 1 by f? 1 by f is focal length is a constant, 1 by f is a constant, so that is equal to 0. That is equal to d by dt of u to the power minus 1, d by dt of image distance to the power minus 1. These are all velocities, isn't it? U is object distance, differentiation of object distance with time, that is velocity. Okay, so 0 is equal to I can differentiate this as minus 1 u to the power minus 2 into du by dt, right? Minus 1 u to the power minus 2 plus du by dt, and this one plus minus 1 v to the power minus 2 into dv by dt, correct? So I will come to this side now. 0 is equal, somehow I have to use the space. 0 is equal to minus u to 1 by u square, because I will bring this downwards. What is du by dt? Velocity, object velocity, right? Velocity of the object. So shall I write it as du by dt only? Du by dt, that is object velocity, minus this is 1 by v square, and this is image velocity, dv by dt. Velocity of the image, this is velocity of object. So rearrange it. What you can do now, when you rearrange it, you bring this here, and we want image velocity, isn't it? We will bring this here. That implies plus 1 by v dv by dt, hope you can see this, plus 1 by v as dv by dt, plus 1 by v square plus 1 by v square dv by dt is equal to minus 1 by u square du by dt. So why minus sign, sir? dv by dt, I will shift it here, dv by dt, velocity of the image. Shall I write it like this? Image velocity equal to this one, image velocity, v square I will bring this here, minus v square by u square into object velocity, velocity of the object du by dt. Shall I write it like that? Image velocity dv by dt is equal to v square by u square with a negative sign and into object velocity. Why it is so? When you run towards, when the vehicle runs towards a mirror, the velocity of the object is positive and image comes in the negative x-axis, negative, right? So that's why you have minus sign. Now there, what is the velocity of the image? How fast will the image be moving? We are ready with the object distance and image distance at the moment. When the object is at a distance of 600 centimeter, image is at a distance of 20 centimeter. We have that the things at the moment. So image velocity is equal to minus v square by u square. V square is almost 20. Shall I take it as 20 instead of 19.66? We will take it as 20. 20 into 20 divided by object distance 600 into 600 into object velocity. If the object is moving at 15 meters per second, of course this is centimeter, but they cancel, right? Because centimeter square gets cancelled. Okay, what will be the answer now? I have to put it here. 0 0 or 2 zeros will get cancelled. Okay, this is 2 300 times and this 2 3 times, and what is this one? 15 divided by 300 into 3, 3 5s are, and 5 60s are, right? 5 60s are, 1 by 60 is 0.1, no, 0.1. 61 times 60, 40 remaining, 6 times, right? Here you have the answer. So this is the velocity of the image, 0.016 meter per second. It looks to be very long, but once you understand this one, okay, you can remember this formula directly. You can do that, right? But suppose you must know the steps. Suppose in case you forget the formula, you can differentiate it and you can get it. So that is the velocity of the image. Okay. Shall we move on? 14th one. We have to rub all these things. Yeah. What does the problem say? A rod of length 10 centimeter lies along the principal axis of a concave mirror. Oh, now it is a concave mirror. Focal length negative. And focal length 10 centimeter, in such a way that the end closer to the pole is 20 centimeter away from it. The length of the image is. It is not vertically placed, it is placed along the principal axis. So what is the length of the image? Not a tough problem, it is an easy problem, but needs some calculations, and you should be very calm and you should be doing it. Concave mirror reflects from inside like this. Let the rod be placed along like this. Like this. The rod is placed like this. Like this. What is the length of the image? Okay. Now, a rod of length 10 centimeter lies along the principal axis of a concave mirror 10 centimeter long. Okay, this is 10 centimeter and of a concave mirror of focal length 10 centimeters. Focal length 10 centimeters means this is a rod of length 10 centimeter lies along the principal axis of a concave mirror of focal length 10 centimeters. Okay. And in such a way that the end closer to the pole is 20 centimeter away from it. End closer to the pole is this one. This is 20. Now is it not 2f? Because focal length is 20, so this is 2f position, correct? Double the focal length. In a concave mirror, when the object is away from the object is at infinity, image is at focus, and this table should be very clear to you. You must be knowing all the ray diagrams. When the object is infinity, image is at focus. When the object is at focus, image is at infinity. When the object is beyond 2f, image is between f and 2f. And anything beyond 2f is larger. Anything between f and 2f is smaller. Whether it is object or image, whatever it is, between f and 2f smaller. Away from 2f larger. So when the object is beyond 2f, image is between f and 2f. Image is smaller, object is larger. When the object is at 2f, image is at 2f. When the object is between f and 2f, sorry, ulta. Image is away from 2f and the image is larger, object is smaller. And that's all. When the object is within the focus, you know it is a virtual and it is only one case, dentist mirror, right? Dentists use that concave mirror as rear view mirror, concave mirror as a mirror to view the teeth. It gives an enlarged image when the object is within the focus. So when the object is at 2f, image is also at 2f, you know. So object, it is double the focal length. What is the length of the image? Yes. Now we will consider this as one object. Okay, and we will consider this point as another object. You consider each point of the top and bottom, the head and tail of the pin or whatever the rod as a separate objects. Find out where they form the image, and if this this is forming the image somewhere here, this is forming the image somewhere here, then the image distance should be V2 minus V1. Where the image of this is formed, find it out, V1. Where the image of this is formed, find out V2. V2 minus V1 or V1 minus V2 will give you the image distance, length of the image, right? So this will be synced somewhere here or here, somewhere else. Now the thing is, see, this is beyond 2f, right? This point is beyond 2f. So the image of this should be formed between f and 2f. What about this one? This will be formed here only. Now u1 is object distance, first one is 20, which is equal to 2f, double the focal length, right? This point is 2f, distance is 2f. Therefore v1 is also 2f. Shall I write it as 20 centimeter? 1 is formed because when the object is at 2f, image is also at 2f, same size. What about this one? u2. For u2 we will find out what is v2. v2 is 1 by f is equal to 1 by u plus 1 by v, and for a concave mirror, when you incident parallel rays of light, they reflect and come back here only, they form the focus here. So focus is, so if you divide it into coordinate system, focus is on the left side of the pole, so you have to move against the direction of the light, negative. 1 by minus 10. 1 by object is in the left hand side. Which is object now? This position is object. What is that position? 20 plus 30. So u2, this is u2 minus 30. Is it not? It is minus 30 on this side plus 1 by v2. Is it not? Is it correct? Yes. 20 plus 30, 10. This end is at 30. So what is this? That implies minus 1 by 10 plus 1 by 30 is equal to 1 by v2. 30 is common, that implies 30 is common. Minus 3 plus 10 3 times, 31 times plus 1. minus 2 by 30. Am I right? Hope I am doing correct, right? 1 by minus 10, 1 by minus 30, 1 by V2 plus 1 by 30 there, 30 common, minus 3 plus 1, so minus 2 by 30 because image distance is on the same side. That minus is okay, I will discuss it later. What is V2? V2 is equal to minus 30 by 2 minus 15 centimeter. And remember, this is also minus, isn't it? Because it is in this side. But that minus is only sign convention. Don't worry about when you subtract the subtract it to find out the image distance. The negative sign says that this point image is formed at a distance of 20 centimeter because object is also at 20 centimeter, 2f. This says that the other end, the tail end of the rod is formed at a distance of 15 centimeter. That means image may be somewhat like this. The image is like this. From here to here, it is like this. Then what is the distance of the image? This is 20 and this is 15. 15 indicates that it is minus indicates that it is on the same side. So 20 minus 15, right? Or difference between 20 and 15. That's what I can conclude. It is not minus 20, minus or minus 15, something like that. So 5 is the answer. That is the length of the image. Length of the image of the rod. Okay. Hope you have followed this, right? So first you find out the position of the image for the one point of the rod, position of the image for another point of the rod, then subtract them, V2 minus V1. That gives the image length. Usually we keep the object like this, so we don't have any worries about this thickness of the object, but this is a peculiar problem. 15. A medium A contains n number of waves, m waves of frequency f in a thickness x, and another medium contains the same number of waves in the same frequency in a thickness y. Then what is the refractive index of A with respect to B? Yeah, this is related to refraction. Yes. Now whenever a ray of light undergoes refraction from one medium to another, like this, it changes the direction because of the change in the speed, and there is a change in the refractive index of the medium. We call this as I and R, 1, 2, velocity here V1, V2, N2, refractive index of the second medium with respect to first is V1 by V2, lambda 1 by lambda 2, sin I by sin R, and only the one thing, the absolute refractive index of the medium with respect to R, second medium with respect to R divided by refractive index of the first medium with respect to R. That is the ratio, that is what. And if you multiply this, we get the usual Snell's law, N1 sin I is equal to N2 sin R. Now, my question is, when a ray of light travels from any wave, when it travels from one medium to another, any wave for that matter, a wave has characteristics like velocity, wavelength, frequency, and you know the relation between them. V equal to nu lambda or V equal to F lambda. In simple way I can write velocity is equal to frequency into wavelength. Which characteristic does change when it travels from one medium to another? Velocity changes. When it moves to optically denser medium, velocity of light decreases. And lambda wavelength changes, but frequency doesn't change. The number of oscillations made by the electric and magnetic fields in the electromagnetic wave doesn't change. Frequency of the wave is the factor which doesn't change when the wave travels from one medium to another. If frequency doesn't change, how can it be so? V by lambda is equal to F. If V increases, lambda also increases by the same amount, so that ratio is same. If lambda decreases, V decreases, lambda also decreases. Now, so when wave travels from one medium to another, like this, here is the question, just to confuse you. A medium A contains m waves of frequency f. Say this is glass. Medium A contains m waves like this. So one wave is starting from one equilibrium position, coming down, minus peak, plus peak, again equilibrium. That is one wave. M waves, that means what is the length, this distance? So shall I write it as m lambda 1, correct? A medium A contains m waves of frequency f in a thickness x. So shall I write it as x? Because a student of 1 feet thick can sit in a bench, right? Suppose 5 students can be accommodated in a bench, each of thickness 1 feet. What should be the length of the bench? 5 feet, automatically. If one wave has a length of if one wave has a length of lambda 1, second one plus lambda 1 plus lambda 1, m lambda 1 is the thickness of the medium. A medium A contains m waves of frequency f in a thickness x, okay, frequency f. And medium B contains the same number of waves of the same frequency in a thickness y. Same number of waves, but frequency same, that we know. In any medium, the same light should have the same frequency, right? If the same light is made to pass into another medium, if the same frequency, that means same characteristic radiation, same electromagnetic radiation is made to pass through the medium B, its wavelength changes, right? When the wavelength changes, they say that, say it becomes broader like this, right? Its wavelength increases, say. When wavelength increases, they say that m waves only are accommodated because this distance y is greater, right? So after lockdown, if same 5 students can be accommodated in the same bench, in another bench, means that bench should be some 7 feet, 8 feet wider. Why? Because after lockdown, every student will be 1.5 feet wider, because after sitting in house, taking good food cooked from your mother only, not going for chats and not going for any outside food, after taking all those items in your house only, when you have enough good nutritious food cooked from your mother, you will grow fatter and fatter, and you will be 1.5 feet in thickness now. If a bench accommodates now also, after the lockdown, after the corona holidays, now also it can accommodate 5 people, means it should be 7.5 feet in length, right? So y is different. Wave if the wavelength is more, that is why same number of waves, m waves. So now shall I write this thickness as m lambda 2, because wavelength has increased. Now 5 into 1.5 feet is 7 feet. 5 into 1 feet, 5 feet. So m lambda 2 is equal to y, right? So now what is their question? Same frequency, so I have to write it here, n2 1, same thickness y. Then the refractive index of A with respect to B. Refractive index of medium A with respect to medium B, here you say. What is this? It is lambda 1 by lambda 2, V1 by V2, okay. Lambda 1 by lambda 2, that is what? Lambda, see here 2 1, right? Lambda B by lambda A, correct? That is what you have to get. N2 1, refractive index of second medium with respect to first medium. Here all first medias, you see. I have rubbed this. See, it is a confusing one usually, but you can avoid the confusion by taking medium 1 and medium 2. 1, 2. Refractive, see, refraction is occurring in the second medium. Light is traveling from first medium to second medium, but refraction is occurring in the second medium. But you can't say that it is the refractive index of second medium only. Why? Because first medium is also responsible. If the light wouldn't have traveled from first to second, how could the reflection occur? So it should have traveled in the first medium also, but refraction is seen in the second medium. So refractive index of second medium with respect to first medium, but in the ratios you get in the numerator, except in one formula, everywhere it is first medium. First medium by second, first medium by second, first medium I, second medium R, and n2 by n1, refractive index of second medium with respect to R divided by refractive index of the first medium with respect to R. So these two are only giving you ulta numbers, 2 1, 2 1, but these are all 1 by 2. So refractive index of second medium A with respect to first medium B, now they are asking you refractive index of A with respect to B, A with respect to B. So here you should have first, second. Now how to get lambda B by lambda A? Divide this, same number of waves, right? So now I will write m lambda 1 is equal to x, m lambda 2 is equal to y, right? Here same number, for example 10 waves can be accommodated here. They are of smaller waves, x, here 10 waves but larger waves, again but this is length is y. But which is larger, which is smaller, I have assumed it, but it is of no use here. So divide them, we want only this one. We want, I have to write it as lambda A and lambda B, otherwise I can't get the answer. M lambda B, M lambda A. M lambda A is equal to x, M lambda B is equal to y. I want lambda B by lambda A. Lambda B by lambda A is equal to y by x. So this is y by x. That is what I want. So option 2, right? So this problem, hope you have followed it, right? Only the idea here needed is when a wave travels from one medium to another, frequency doesn't change, wavelength changes, and the ratio is like this. And here they say that m number of waves are accommodated in a thickness x. That means wavelengths are maybe smaller or larger. Here they may be different. In a distance y they are accommodated. So now the same problem can be asked in another way. In the same thickness, different media, say glass and water, I will put it here. In the same thickness but different media, right? Say, or shall I explain it here? I have to worry about all the wires and all. Yeah, in the same thickness but different media. Now what is the difference? I will put the same electromagnetic radiation, say red laser beam, in glass of thickness x and in water of thickness y. Medium A is glass, medium B is water. Now what is the problem here? Problem is you can't accommodate same number of waves, right? Your teacher asked you to sit down in the same bench what you were sitting earlier before Corona holidays. Now 5 people cannot be accommodated. Isn't less number of people, only 4 may be accommodated, even not 4. So in such a case, we see here, number of waves, say it is say this is, both are x now, right? Thickness is x. Say number of waves here is I will take number of waves in some other way. So I want to get a ratio of x and y, right? Say what I can assume here. Say p number of waves are accommodated in this thickness x and q number of waves are accommodated in thickness y, in medium b. What is the ratio of, so now what you will accommodate now? Here p number of waves into lambda a, p number of waves into lambda a is equal to x. Here the thickness is same but number of waves is different. Q number of waves into lambda b is equal to x, right? Now you have to get the ratio in terms of p and q, that's all. What is the refractive index of b with respect to a? That is 2 with respect to 1. Lambda 1 by lambda 2, lambda a by lambda, a with respect to b, right? Refractive index of a with respect to b is 2 with respect to 1. Lambda 1 by lambda 2, lambda b, refractive index of a with respect to b, second medium with respect to first medium, it is lambda b by lambda a, right? First medium by second medium is equal to, if you want to get lambda b by lambda a, divide them. Q lambda b must be equal to x, which is equal to p lambda a. Lambda b by lambda a is equal to p by q. It is p by q, like this. So you should be a little bit concentrated when you solve this problem. Okay, we will move on to one more question. Our video, our time is showing just 5 minutes, 16th one, yes. This is also related to refraction. Okay. A graph is given, sin I versus sin R. It is a constant always. For a given medium, sin I by sin R is a constant. Refractive index of one medium with respect to another. That is ratio of sin I by sin R. It is given that it is 60 degrees, right? That line makes an angle of 60 degrees. This is 60 means if you take a slope, here you get sin I variation and here you get sin R. Now slope is equal to sin I by sin R is equal to tan theta, isn't it? If this is taken as theta, slope is also tan theta. Mathematics I need not explain you. You know it very well. And what is tan theta? Tan 60. Sin 60 is root 3 by 2. Cos 60 is half. So it is root 3. So this is refractive index of second medium with respect to first. Anything is anything given here, and medium at an angle R. Second medium is R. Sin I by sin R is shown from the one where this can be concluded that yes. Medium 1 to medium 2. Ray is traveling from medium 1 to medium 2. Okay, second medium, incident on a medium at an angle I and refracted into a second medium at an angle R. The graph of sin I versus sin R is shown in the figure. From the one we can conclude that yes, n21 is equal to sin I by sin R, that is equal to that is equal to root 3. What do you mean by that? Refractive index of the second medium with respect to first medium, n2 by n1 is root 3. So what you can conclude now, the velocity of light in the first, this is also equal to velocity of light in the first medium divided by velocity of the light. This is the only formula which is ulta, right? Yeah, v1 by v2, lambda 1 by lambda 2, all you know. Velocity of light in the first medium is 1.732 times the velocity of light in the second medium. Exactly. Velocity of light in the first medium is 1.732 times the velocity of light in the first medium. Correct? What about the second one? The critical angle for the two media is given by sin IC is equal to 1 by root 3. You know that sin IC is equal to 1 by n, right? 1 by refractive index of the second medium with respect to first. It is 1 by root 3. 1 by root 3, correct. This is also right. Refractive index of the critical angle for the two media is given by sin IC is equal to 1 by root 3. That is also correct. Both A and B are correct here. Yes. This is the correct answer. You should be very careful. So option 1 and 2 are correct. So it is the conclusion. So just see whatever what is out of syllabus here. It is within the syllabus, but you have to analyze it. But for the theory exam, what we do is we study Snell's law. It is the ratio of sine of the angle of incidence to sine of angle of reflection. But here you have to analyze it, right? Shall we move on to one more question? Yeah. If c is the velocity of light in vacuum, then the time taken by the light to travel a distance x in a medium of refractive index n is. Did you understand what is told in the problem? If c is the velocity of light in vacuum, then the time taken by the light to travel a distance x in a medium of refractive index n. C is the velocity of light in vacuum. And if v is the velocity of light in a given medium, the time taken by the light to travel a distance x in a medium of refractive index n. If there is a medium of refractive index n, and if this is r, you know that when the light travels from r to certain medium, if v is the velocity of light in the given medium, then if c is the velocity of light in vacuum, then n is equal to refractive index of the second medium with respect to first. Second medium is the medium. First medium is r. So I don't write anything. It is the velocity of light in the first medium, velocity of light in the second medium. And it is given, if c is the velocity, okay, we can use it. Now the light has to travel a distance x in a time t, right? To travel a time, what is the time taken? Time taken by the light to travel a distance x in this one. So expand this one. N is equal to c by distance traveled by time. Ct by x, right? We have to express time in terms of any one formula. That's all. So expand velocity as distance traveled by time. Distance is one of the data. So n is data. Only t is to be asked. Xn by c is the time taken. Xn by c, you have the answer. Xn by c. So that is the thing about this. So today's question, we will go to prisms in the next class, right? So for the timing, I'll stop it here. So try to answer those questions. Don't wait for the class. But if you look into the questions once already, it becomes easy to follow it. Otherwise, you will be looking into a fresh question, and it becomes you will take time to understand it. Hope you will do that. So let us move on to the next class. Thanks for watching my class. We'll meet in the next class. Thank you.